Okay, guys, we're back again. We're continuing our work. All right, so this is, let me see, let me bring this guy here. So positive association is this one, okay? This is called positive association. This is called negative. This is nonlinear. Linear means a straight line. And so is this. D is also nonlinear, and there is no relationship. So keep those things straight. All right, guys? All right. How do we measure this relationship? So I'm gonna give you a little bit of theory first, then we're gonna do some math. All right. So to find the relationship between two samples, number of hours you spent studying, and the grade you got, what we do is for each variable, first we find the mean and the standard deviation. From each number, we subtract the mean divided by the standard deviation. And we do the same with the second variable. We multiply them and add them all up, then divide it by n minus 2. This is called Pearson product moment correlation coefficient. Okay, so take a look. I'm going to do a calculation based on this. Okay, so don't worry too much. So this is the formula we're going to use. And this coefficient that you're going to get has some unique properties. What are the unique properties? And you want to know them. You want to know them. There will be questions on MATLAB 4.1. Questions are related to these. And 4.1 will be on the final. And you should be able to do the 4.1 problem by the time we wrap up, by the time we finish our lesson. So this formula that we use to calculate the Pearson correlation coefficient has some properties. This will always be between 1 and -1. Okay. 1 means strong positive correlation, -1 means strong negative correlation. The closer R is to 1, the stronger the evidence of positive association. When 1 goes up, the other goes up. The value of R is really close to -1. That means there's a strong negative correlation when 1 goes up, 1 goes down. A negative correlation would be the amount of time you spend watching, let's say, Netflix movies and your grade. If you watch, the more Netflix movies you watch, hopefully you don't do that, your grades will go down. So that's an example of negative correlation. Your health will go down if you don't exercise and eat good. That's another example of negative correlation. If the R value you get is close to 0, there's no correlation. The linear correlation measures the assertion, so the unit measure. Let's read number 7. The linear correlation coefficient is a unitless measure. Okay, so it's a unitless measure. You can measure two completely different quantities, number of hours and grade. Okay, so don't worry about the unit, it has no unit. The correlation coefficient is not resistant, so a little data change will affect the correlation coefficient. So this R value is called correlation coefficient, sample linear correlation coefficient. Sometimes people call it Pearson product moment. And these are the properties. This is the formula. Yeah. All right. So guys, I'm going to go to Excel. Okay. I'm going to go to Excel and try to find this. And there are problems like this on BlazeView, on MATLAB. Okay. So let's open it up. I'm going to enter the data. So you have to be a little patient with me. I will try not to mess up, but let's do this. Let's do this. All right. So guys, X and Y, now they're giving us the mean and the variance. I'm gonna just use them because I know how to find it. I know you know how to find it. So I'm not gonna waste our time, okay? I'm gonna call the variables X and Y, and I will try my best to enter the data without making any mistakes. So 1, 2, 3, 3. So it's just a problem example from your book. 1, 2, 3, 3, 6, 7, 1, 2, 3, 3, 6. Okay, and this is 18, 13, 9, 6, and 4. And we'll check our answers. 18, 13, 9, 6. 18, 13, 9, 6, 4. Okay, there's no. All right, it's a small data set, right? The mean of the first one is 4. Okay, I'm going to write here mean x is 4, and the SX standard deviation is 2.44949. Okay, I'm going to save it here. I'll show you why. And mean y, it looks like the word my is 10, and SY is 5.6124872486. Now, now you have to find it sometimes, okay? And you know how to do it. So I'm gonna do this. Now, what am I gonna do here, guys? I'm gonna make this column, okay? Every variable minus the mean divided by standard deviation. I'm gonna do it here. Let's call this the first one A. This guy minus the mean and divided by the standard deviation. Correct standard deviation, right? 2.44949. I'm getting this. Yes, this will be, some of it will be negative, some of it will be positive. And the next one, B. All right. B will be the second data set, the Y values minus the mean of the Y values. And then I have to divide it by the standard deviation of that set, 5.612. And I'm going to drag it all down. Now, in the third column, let's call this column C. I will be multiplying column A and B. I'm doing right here. Now let's check. Did I get some of them right? Yeah, 1.224, 1.4. So we're doing so far so far so good. So I'm going to multiply these two guys. This times this. And yeah, we're getting it right. Let me see. Yeah, not bad. I'm going to find the sum. Okay. And then I'm going to divide it by n minus 1. This sum of this column is this. Then I'm going to call it P. My correlation coefficient is going to be this guy divided by, what am I doing here? I found the sum and I got 3.78. So far, so good. I'm going to take the sum and divide it by n minus 1. And I think it's 5. So I'm going to divide it by 4. All right. And it's 5, 1, 2, 3, 4, 5. It's a sample, or it's defined, you divide it by n minus 1. So I divide by 4. I'm getting 0.95. Okay. 0.9546. Let me check the answer. 94546. Negative 946. Not bad. Not bad. We didn't mess up. That's all I'm saying. So this is what we learned today, how to find correlation coefficient between two variables. And negative 0.9 is, I would say it's very close to 1, negative 1. So it is a strong negative correlation. And we can see it right here. When x is small, y is very strong. When x is high, y is low. Another thing, guys, this is called correlation, how two things correlate. This is not causation. Causation is different. Don't confuse correlation with causation. For instance, one summer, people figured out that kids were having a lot of ice cream and they were losing weight. Okay. Now, of course, that can be possible, right? Ice cream cannot cause you to lose weight. What was going on is that it was summer and kids were eating ice cream, but they were also doing a lot of biking. So biking helped them lose weight and stay healthy, but ice cream didn't. So don't confuse correlation with causation. Causation is something completely different. It's harder to prove mathematically. Pearson correlation coefficient simply says when one variable goes up, the other goes down, or when one variable goes down, the other goes down. When one goes up, the other goes up, all those things. Now, it doesn't say one is causing the other to go up. So don't confuse correlation with causation. Again, if you need help with any of the problems, ask me, email me. I will be happy to work it out with you, maybe do a video. You should be able to do 4.1. You shouldn't have any trouble. 4.1 problems from MATLAB have all been uploaded. There are a couple of problems like this, and some of the problems are just conceptual, things we kind of went over today. All right, guys, thank you again. I will see you in our next video tomorrow. Take care and bye bye.